Okay, so for problem number 30, it doesn't look easy, but rest assured that these problems are written to really give you nice numbers. So the first thing I would recommend doing is, basically thinking about it. It's x raised to a power. So kind of looking at, before I go forward, I want to point out if we're in a real number system, x has to be greater than 0, right? Number one reason we're taking the root of x, and the radicand must be certainly greater than equals 0, but we're dividing by that, so it can't be 0. So it kind of restricts my solutions to numbers greater than 0. The next thing I'll do is, trying to simplify it, is probably write down, let's put this down over here, y equals, I'm going to say the root of x. All right, and let's see if that helps us out at all. All right, this is a substitution. So that means y squared would equal to x. All right, let me write this down then. And so I'll write down y squared, that's what x is, to the power 1 over, well, the root of x is just y. And that equals the number 2. All right, then the problem comes is, does that make it any better? Well, at least I don't see a root in the problem anymore. All right? I'm kind of looking at this and saying, well, gee, I could probably raise both sides to the y. And let me put that down. What would you get? You get y squared is equal 2 to the y. Well, at this point, I'm starting to realize that there is a very simple solution to the problem, and that's y equals 2. All right, that's a really simple solution to that problem over there. And let's just go through that to make sure that's true. If y is 2, that means the x would be 4. All right, so what I'm going to do here is just see if that's true. So you get 4. Again, we're checking it here. So what do you get? You get 4, and then you get 1 over. Well, the square root of 4 is 2. And what does that mean? It really means the square root of 4. And the square root of 4 is indeed 2. So that works out beautifully. I get this. All right, that's as good as gold. I realize that, a lot of times, and myself included, I look at this and say, I wonder if there's other ones. I wonder if there's other solutions over there. What I would kind of recommend is, maybe looking visually at it. And what I mean by that, which I know seems strange to you, I'm gonna write down, if I were thinking about this, and it does look strange to me, by the way, I'd be graphing out two things. I know this looks strange. I'd be graphing out, y equals x squared. I want to point out what we're really trying to do. I'm trying to visualize this. And the other thing I want to graph out is, y equals 2 to the y. Now, you may wonder why I do it this way and not writing down x equals y squared and x equals 2y. I can visualize this very quickly because it's familiar to me. I mean, this is looks like this over here. I mean, that's a parabola. That's really easy. And then I get this exponential, and the exponential is certainly going to look like this over here. Now, by the way, the exponential is going to kick up speed, and it's going to come back up, and it's going to go much faster than that parabola. So it'll be another point over here somewhere, all right? So I see 3. Now, seeing 3, just visually seeing 3 over here, I know there's going to be a negative y, so there's 3 solutions. So I'm going to say there's 2 positive ones. We already found 1, by the way. We know y is 2 works. What about the other one? I'm going to say this is 2 here. And there's going to be another one that's certainly greater than 2. But there's also one negative one. This is not going to be considered, though. I'll tell you the number one reason not being considered is, looking at this original statement over here that we said that y was equal to the root of x. And the root of x is principal. It's a positive number. Should say non-negative. So I'm going to cross this out. And we're left with thinking about this. And again, just thinking about it, I know there's another one above the 2. So what I'm going to do is make a stab at it. And so I'm going to say, I would go with integers first, because if it's not an integer, I got troubles. I get to go to logs and things like that, and I don't want to go there yet. So 3's not going to work, by the way, because 3 squared, y being 3 squared would be 9, and then 2 cubed is 8. That's not going to work. Let me try 4. All right, let me try 4. And if you tried 4, what would you get? You get 16 on the left, and you get 2 to the 4th. And what's that going to be? 2 times 4 That's 16. That worked beautifully. So if y is equal to 4, x would be equal to, and again, I want to point out what I mean by that. We're over here. X would equal to 16. We got two solutions to the problem now. All right, let's take a look at the key. And again, I think it's a tricky problem, by the way, but I do list those answers for you. So I list, we found the y to 2, x was 4. That's an obvious solution, I'd say, over there. And the other one, less obvious until I kind of thought about it and graphed something out. I get this over here. I'm sorry, I didn't mean to outline that and go backwards. I meant to outline this over here. X is 16. So again, there's two solutions to the problem that we found through some thinking and work. So the solution to this problem over here, x would equal 4 or x equals 16. Again, you can check those if you want. Maybe we should check this 16. What do you get? 16, and then you get 1 over the square root of 16 is 4. And the fourth root of 16, well, it's really the square root of 16, which is 4, and the square root of 4, which is 2. That does work out. They both work out, by the way. All right, so 4 and 16 are the answers. I also want to briefly talk about the graph. And the graph is on, let's see, figure 102, 264. It's right over here. And in the green, let me just point out what I mean by that. The green curve is the graph of y equals x to the 1 over root x. And the magenta curve is the line y equals 2. Do they have points of intersection? They do. There's a point here, and there's a point over here. Let me just get my ruler out. And again, it's nice to have a visual. A machine is creating these visuals, by the way. And I hope you realize that solution there, just looking at it, certainly that appears x is 4. Let's do the other one. And this one over here, be very careful about lining it up. It looks about 16, all right? Now, granted, you can zoom in to these pieces of paper over here. They're digital paper, and you can see there's a separation there. There's a point of intersection there. Again, the point of intersections occur here at the number 4. This is a point 2. The solution is x equals 4, though. And this one over here occurs at 16, and you get 2. And again, the solution is x equals 16. We found those things. It's nice to have a visual, though. Thank you.